Alright, this is a review or kind of just general guidelines to help with balancing equations. I wish they were a simple, easy thing and there was just like a step 1, 2, 3 I could tell you to get through each one, but there's not. But just some things to keep in mind so you don't make silly mistakes. So if you think about having something like this, H2O or O2, alright? These subscript numbers can never ever change. Those have to be left the way they are because that tells you what molecule you have. If you change those subscripts, then you're turning it into something else and then it's no longer the same reaction. And the only thing you're allowed to do is increase the number of molecules by adding in those bigger coefficient numbers. Okay? But something to keep in mind with those multiply each atom in the molecule. Alright, so it's almost as if you have H2O in parentheses when you add those in there. You just don't have to include the parentheses. Okay, so keep in mind, you're not allowed to change coefficients. Those must stay the same. Subscripts. But the coefficients you can add, and you can add as many as you need to in order to get things balanced. Alright? Plus, to reiterate from the packet, the idea of balanced is that you have the exact same number of atoms on both sides, and even more importantly, the exact same number of each kind of atom on both sides. So that's that. When I show you a few sample problems, that's going to be the way to make sure that you don't make mistakes, is at the end, double check and make sure that the atoms on left side are same number as the atoms on the right side. Okay? So, couple sample problems. This one's pretty easy. It was also in the packet. Alright. When you have these, you're just trying to balance out your numbers. So we have H2O, which is 2 hydrogens, 1 oxygen, and then H2, which is 2 hydrogens, and O2, which is 2 oxygens. And you know you're not balanced because there's an extra oxygen on this side. Okay? So, first thing you want to do then is, well, we need to increase oxygens on the other side. So let's throw a 2 in front of this. Now our oxygens are good, except this makes it so that we have 4 hydrogens. And then there's only 2 now on the right side. So you just have to put in one more number. Right? You just keep playing with those coefficient numbers until you get everything canceled out. So, and then also something on tests and quizzes that I want to see is just that step. Like, if you don't show me any other work, you don't have to draw pictures like there were in the POGIL, and you don't necessarily have to show me your whole entire thought process, but at a minimum, I want to see you double checking and counting the atoms on each side. So what that would look like is, on the left side, H, we have 2 times 2, so that's 4, and then oxygen would be 2, and then there's no subscript after that, so that's just 1, so that we'd have 2 total. And then on this side, 2 times 2, hydrogens are 4, and then O2, oxygens are 2. As long as they're equal, then you know you're good. This is the way to double check and make sure that you haven't goofed up, made a mistake, missed something. Okay? If you take the time to sit there and recount it at the end and write this out, it should catch mistakes if they happen. So, another one, especially if you see something like a single, elemental form of something. Typically speaking, balance that last. Because if you can make everything else work out, then you can go there. Alright? Now, this one isn't the best example for that because if you look at your other atoms, we have 1K, 1Cl, 3 oxygens, 1K, 1Cl, 2 oxygens. So we have to sit there and mess with the oxygens. Alright? So initially you might think, well, let's double. That's going to make 4 oxygens. But then we still don't have enough over here. So doubling is not going to be enough. So let's try tripling. So that's going to give you 6 oxygens on this side. And then you can very easily get 6 oxygens on this side if you double the KCl. But because you doubled the KClO3, now you have extra KCl's on this side, so we have to double that. And then the work I expect to see is that on this side of the equation, K, we have 2 potassiums, Cl, 2, oxygen, 6. And then on this side, we have 2K, we have 2Cl, and oxygen is 6. They all match up, then we're good, we can move on to the next problem. So, we'll get into these, but you're going to see these reactions a fair amount of times. This is the ones where it's really good if you just wait to figure out oxygen till the end. Alright, so try balancing your carbons and your hydrogens first, and then hopefully all we'll have to do is have some sort of multiplier on the O2 to make it balance at the end. So we have C3H8. So to balance the carbons, we would need to add, we have 3 on this side, 1 on this side. So let's add a 3 in front of there. We have 8 hydrogens on the left and 2 on the right. So if we put a 4 here, that'll balance those. And now we need to see how many oxygens we have on that side. So 3 times 2 is going to be 6. And then 4 times 1 is going to be 4, so that's 10. And luckily that's divisible by 2, so that's easy. We just make this a 5. Okay. Then go through and double check. Carbons are 3, hydrogens are 8, 5 times 2, oxygens are 10. Let's see, 3 times 1, carbons are 3, hydrogens 4 times 2, that's 8, and then we have 3 times 2, which makes 6 oxygens here, and then 4 times 1 is 4 oxygens, so for a total of 10, which means we're good. So, last one, this one's a toughie. Alright, and this is what I mean by there's no simple, easy way to get yourself through this. To be truly honest, 4 people would probably attack this one. They'll all come to the same final answer, but they'll probably do it 4 different ways. Okay? Now, I have the luxury of already having done this, so I kind of have a feeling for what the outcome has to be. But this one, originally, it took me a good 15 minutes to figure it out. So I'd say give yourself the challenge and try it. So turn the video off, give this one a shot, see if you can get it on your own. It's one of those problems where you invest the time and then it actually feels really good that you got it right on your own. Okay? But one thing, this one has that elemental copper. Don't worry about copper. You can see even at the moment it's already balanced. Okay? So that's something where when we figure out what works, we're just going to throw a number in front of the lone Cu. Alright? So, what we have is we have 1 copper, 1 hydrogen, 1 nitrogen, and 3 oxygen on this side. We have 1 copper, hydrogens, we have 2, nitrogens, we have 3, and oxygens, we have 6, 7, 8. Alright, so just looking at our numbers, you can kind of tell that we're going to have to increase the HNO3, because we need to increase our H's, our N, and our N's. And that's also going to help increase our oxygens. So, first thing you might try is throwing a 3 in here, because that's going to get your nitrogens to where they need to be. So, with the 3, that gives us 1 Cu, 3 hydrogens, 3 nitrogens, and 9 oxygens. So if you look at those numbers and compare them to the ones on the right, our nitrogens are good now. Coppers are still okay. Hydrogen is only 2, and we need to get it to 3. But that's an H2, so that's not something that's going to be easy to do. And then oxygens, we only need 1 more, so you could increase your H2, that would give you the 1 more, but that's still going to be off. So 3 probably isn't going to be the best number for that spot. there's also, if you sit and kind of think about this and you look at that, like, okay, so an odd number here is messing me up because of the hydrogens. So I probably have to have a positive number there. Another thing that kind of throws you off is if you always have a positive number here in the HNO3, that means you're always going to have a positive number of oxygens. Okay? This is always going to be some multiple of 6 in this spot, so that's going to be an even number of oxygens. That's fine. But these guys, they are singular. So they have to be, in order to get even numbers, like they both have to be even or they both have to be odd. All right? So it doesn't work for, for me to use one NO and then 2 H2O, because then they won't add together to make the right combination. And then if you think about it even further, the N is attached to this N, which is going to be positive, which has to have an even number, and this N here is always going to be even. So this has to be an even number. If you're not following this, it's no big deal, but essentially I'm coming to the conclusion that these 3 spots must have even numbers in them. Any odd number there is not going to work. Okay? So let's try throwing 4 in there. We're going to do 4 HNO3s. So Cu is 1. We'll have H is 4. N is 4. And O is 12. Alright. Then we're still comparing it to these original numbers over here. We got to find a way to get these up. So let's see, to get H is the easy one. There's only 1 on the right side. So let's put a 2 in here, because that's going to fix our H's. And then our N's, if we want 4 of them, we've got 2 in here, so let's try throwing a 2 right there. And see what numbers that gives us. So Cu is going to be 1, H is going to be 4, N is now 4. Alright, so we've got some good numbers here. Then we have to count our oxygens. So we're going to have 6 right here. And then 2 and 2. So that gives us 10. So that one still doesn't work. Alright. So if I throw in, next thought might be is to go to 6, but if you put a 6 in here, to get that to work on the other hydrogen side, you'd have to throw a 3 in. And we already discussed that those can't be odd numbers. So I'm actually going to go up 1 more. So let's erase what we have in here. Choose a new color, go green. I'm going to erase this so I can write it here. You can still see it. Let's try 8 here. 8. So on this side, that's going to make Cu of 1, H, 8, N, 8, O, 24. Alright, so to get our hydrogens to balance out, I have to throw a 4 here. And then nitrogens and oxygens, we need to increase our oxygens by a lot. So we know we need an even number NO, so I'm going to try putting a 2 there. And then see if maybe increasing my Cu number is going to help. Okay? But let's see where we are there. Cu, still 1. H's are 8. My N's right now are 1, 2, 3, 4. And I need to get those to 8. So let's put a 3 in here so we make that 6. That's actually going to make our coppers 30. And then our N's are now 8. Then let's check our oxygens. So we have 6, but the 6 here, but that's going to be times 3, so that's 18. Plus 2 is 16, plus... I went totally the wrong direction there. 18 plus 2 would be 20, plus 4 is 24. And you found your combination that cancels everything out. Except, what have I not noticed? This is one reason why you always want to go back and double check and recount them again, because what did I miss? Hopefully you are noting my copper over here. It's one reason to sit there and take a step back and recount it all from the very beginning. Alright? Because I need to put a 3 in front of the copper. So this is definitely a hard one, and it takes a while to get through. And every once in a while you get ones like that. It depends on the reaction we're dealing with. Okay? So please bring any questions that you have to school on Monday.